sitting in a flashing metal capsule. Lights blink. A countdown reaches 0. The machine shakes violently, and then everything stops. You open the door and step out into a different year. That's how time travel works in movies. But in reality, nothing like this happens. In everyday life, time feels like a flowing river, but physics tells a different story. Einstein showed that time is a dimension woven together with space into a single fabric called space-time. Just as you can move left or right in space, objects move through time, but not always at the same rate. Once time became a dimension, the idea of time travel stopped being fantasy and became geometry. If space-time can bend, then paths through time can bend too. And that realization leads directly to the first kind of time travel we already know is real. Traveling into the future is not theoretical. It happens every day. According to relativity, the faster you move through space, the slower you move through time. This effect is called time dilation. Astronauts aboard the International Space Station age slightly slower than people on Earth. GPS satellites experience time differently than clocks on the ground. Without correcting for time dilation, navigation systems would fail. This means if you travel near the speed of light, you can leap into the future. You leave Earth, you travel fast, you return. Everyone else has aged more than you. No paradox, no contradiction, just geometry. But this kind of time travel only moves one way, forward. The real question is the one people care about most. Can you go back? Traveling to the past is far more complicated, not because it violates physics immediately, but because it threatens causality, the principle that cause comes before effect. If you could go back, could you change events? Could you erase your own existence? Could the universe survive logical contradictions? These questions force physics to confront not just equations, but consistency. To explore backward time travel, we must look at the most extreme distortions of space-time. And that brings us back to black holes. Near a black hole, time slows dramatically. From far away, clocks near the event horizon appear to freeze. Inside, space-time is so distorted that all paths lead inward. Some mathematical solutions to Einstein's equations describe black holes connected to other regions of space-time, structures known as Einstein-Rosen bridges, or more commonly, wormholes. Originally, these bridges collapse instantly. They are not traversable, but if, and this is a massive if, a wormhole could be stabilized, it could connect two different points in space-time. Not just different places, different times. A wormhole is a tunnel through space-time. Enter one mouth, exit another. If one mouth experiences time differently than the other, for example, if it's accelerated near light speed or placed near strong gravity, the two ends become desynchronized in time. Enter the younger mouth, exit the older one. Congratulations, you've traveled to the past. The equations allow this. Physics does not immediately forbid it, but nature raises objections. To keep a wormhole open, you would need negative energy, a form of exotic matter that repels gravity. Tiny amounts of negative energy exist in quantum physics, but nowhere near what would be required. As far as we know, macroscopic quantities of exotic matter may not exist. This is nature's first warning. Time machines are mathematically allowed, but physically hostile. Still, suppose we overcome that obstacle. A deeper problem remains. Backward time travel creates paradoxes. The most famous is the grandfather paradox. You go back and prevent your grandparents from meeting. You are never born. But if you're never born, you never went back. This isn't just a storytelling issue. It's a logical contradiction. Physics dislikes contradictions. So how does the universe respond? There are three major possibilities. The Novikov self-consistency principle. This idea says the universe only allows self-consistent timelines. You can go to the past, but you cannot change it. Every action you take was always part of history. You didn't alter the past, you fulfilled it. In this model, free will exists, but only within paths that preserve consistency. The universe becomes a closed loop of cause and effect. Many worlds, you create a new timeline. Another solution comes from quantum mechanics. In the many worlds interpretation, every quantum possibility creates a new branch of reality. If you travel to the past and change something, you don't overwrite your original timeline. You create a new one. Your original universe remains intact. You've simply left it behind. This avoids paradoxes, but at the cost of multiplying realities. Stephen Hawking proposed that the universe may actively prevent time travel. As a time machine begins to form, the quantum effects grow infinitely large, destroying the structure before it becomes usable. This idea is called the chronology protection conjecture, the notion that the laws of physics protect causality. In short, the universe refuses to allow its own history to be rewritten. This idea has no definitive proof, but it aligns suspiciously well with reality. Interestingly, many paradoxes arise not from physics, but from how humans experience time. We perceive time as a flowing present, but in relativity, there is no universal now. Different observers disagree on the order of events. Past and future are not absolute. They depend on perspective. This suggests something profound. Time travel feels impossible, because our brains evolved to experience time locally, not globally. The universe may not share our intuition. Time travel also depends on whether time extends infinitely backward. According to current cosmology, time began with the Big Bang. There was no before, because time itself did not yet exist. If time has a beginning, then backward travel may be limited by that boundary. You cannot go earlier than the start of time, any more than you can go north of the North Pole. This suggests that time travel, even if possible, is constrained by cosmic history. Time travel to the future allowed, observed, actively used. Time travel to the past, allowed by equations, requires extreme conditions, creates deep logical challenges likely blocked by nature. The laws of physics don't scream impossible, they whisper be careful. Time travel is not about machines and flashing lights, it's about how space-time is structured, how causality is preserved, how consistency is maintained. It is the consequence of time being a dimension, the result of gravity bending spacetime, the tension between relativity and quantum mechanics, a test of whether the universe allows contradictions. Time travel shows us that reality is not built for storytelling. It's built for consistency. The future is open, the past is fixed, and the present is just the place where your path through spacetime happens to cross. Whether backward time travel is possible or not, the question itself teaches us something deeper. The universe is not afraid of strange ideas. It is only intolerant of broken logic.